here. This is Ed Jaselskis, professor at NC State. Before I get started, I just want to say we really appreciate this opportunity to speak with this group for a little bit about a really interesting project that we're all involved with the North Carolina Department of Transportation. And so the people who are speaking or part of this presentation are as follows. Dr. Arnav Jalla, who's a computer science professor at NC State. Colin Potts is a PhD candidate at NC State. Sid Banerjee, PhD in our department, civil construction and environmental engineering. And Claire Fullerton, who is the program manager for this particular project. It's called CLEAR, and she'll explain that in a little bit. So I guess actually maybe I should turn my my video on. Let's see, did I do it? Yeah. Okay, so we'll go to the next slide. Here's the outline for our presentation. I'll give an overview of our talk today. Claire will talk about the motivation behind developing the CLEAR program at NCDOT, and then we'll kind of get into the details of natural language processing and the AI tool that was developed for our lessons learned database, and Arnav and Colin will discuss those bullet points that you see there, and then we'll have some time for Q&A. So we have 30 minutes. Figure the presentation might be around 15 minutes, 20 minutes max, so we'll have about 10, 15 minutes for Q&A. So we'll go to the next slide. As far as an overview, you all know the importance of capturing lessons learned to try to reduce mistakes in the future. Lessons learned is a CII best practice, and really great report that was produced. I do know that many organizations have such programs, but also know that the benefits of these lessons learned programs are not fully utilized. And I had a particular example working as an intern for a CI company that had a really nice lessons learned program that it seemed like not many people knew about or used for different reasons. Anyway, so this particular project, let's look a little bit about the background. Started probably about 3 years ago with the NCDOT, where NC State had a contract to help them create a lessons learned database. It was formerly called the Post-Construction Assessment Program. Now it's been changed to the CLEAR program. And so that's what we did. We helped basically provide the necessary input and design for the lessons learned database. And actually, I'll be honest with you, we used the CII best practice pretty heavily in terms of following guidance that was suggested to create such a program. So it is now being rolled out, and there are some sticky issues that maybe Claire will talk about, but that led us to think that we need to do something to get people to really engage and use the lesson learned database. And we thought that AI might be a good approach, a good solution. And that's where we teamed up with the computer science department at North Carolina State University to show what we had and see if they had any ideas about how to quickly and efficiently identify lessons learned for the project managers and the project team for their new projects, instead of what I found when I would go into lessons learned databases in the past. It's kind of cumbersome to do the search. You don't know exactly what's in there. You don't know if you're getting all the lessons or best practices that are in there. So we thought AI could be a potential solution, and that's the direction we headed. So we've been working with this and developing the tool over the past about 6 months or so. So with that, I'm going to turn over the presentation to Claire, who's the program manager in charge of this lessons learned database for NCDOT. Claire?
Thanks, Ed. Yeah, so CLEAR stands for Communicate Lessons, Exchange Advice, and Record. And it's the department's internal knowledge management, or KM program, that is really the hub of our internal innovation efforts for the department. So the program works to support the solicitation and review of innovations and lessons learned, and spearhead cross-discipline and cross-unit communication and knowledge sharing. And as Ed mentioned, the program has been going through a systematic rollout for about a year now. And we are a really diverse organization of nearly 9,000 employees. So our approach has changed and adjusted as we've kind of been going through that over the last year. One of the things, or really the main thing we're really working on right now, and what you're going to hear about more from Arnav and Colin, is how do we make the knowledge and innovation share easier to access and apply? Because we want to make sure this program is more than a database or repository of information, and we really are working towards making it a larger part of our culture of innovation and communication. And as Ed mentioned, this program has taken several years to develop. I started working on it when I came to the department in 2017. And honestly, the biggest barrier to overcome has always been on the people side of it and the necessary culture shift that needs to go along with it. But what we are doing here and what you're going to hear about is a really creative way to get the program to work better for the personnel, rather than trying to get the personnel to change the way that they do work with the program. And so really just the initial findings that have come out of this work over the last 6 months has really shown that it's going to propel our culture of innovation and our knowledge management program forward with leaps and bounds over the coming year. So I'm really excited to see how that all unfolds. And so thanks.
So hi, I'm Arnav. So we said, how do we, Ed came to us with this question of whether AI could help, figure out how to get people to interact better with this information. And AI is a big term, so I will actually first start by sort of defining what we mean by AI in this project. So we think of AI as a computational tool, much like your physical tools, but for the cognitive processes, right? So it's a cognitive enhancement tool, and the way in which we are using AI in this case is to say we have all of these lessons learned that are entered over many years, and we look at how data is represented, right? What kind of data it is that's in there, and we see on the right here is an example of a best practice that's in the CLEAR database, and this includes raw text and some metadata about where that text is from and so on. The details of the text are not relevant here, but the idea is that we have a lot of different types of information and sort of a lot of it that is there. And one of the successes of AI, I would say the top success of AI has been search, right? In fact, that is kind of what made AI go mainstream, is efficient search. And so underneath the Google search is an organization of information in a way that makes it easy to find meaningful information for what you're looking for. And so in this project, we take the same approach. We say, how do we create meaning and relationships between these disparate pieces of information? And for this, we use natural language processing technologies, which Colin will describe in a couple of slides. But we also focus a lot on how to present this information. So there's on the back end is a language model that organizes all of this information, and on the front end is an interface that allows a user to quickly and efficiently look for relevant pieces of information to what they need for their project. So I will, in the next slide, Colin will introduce the language model and go into a little bit of details.
Thanks, Arnav. So hi, everyone, I'm Colin, and I'm going to talk to you a little bit about the AI model that we're using here. So we start by essentially, we want to take a lot of text that is relevant to transportation and construction. So that could be contract documents, feasibility studies, specifications, really kind of any piece of text that we can get our hands on. So we build up this huge corpus of just natural text that people have written. And we're talking at least 1 million words, hopefully more, like a very large corpus, lots and lots of text. And what the model starts doing is it starts looking through there and it starts essentially learning how those words work in a construction context. Because I'm sure you're all aware, you have particular acronyms, you have different ways that you're going to use words than, say, just normal English language. And so then the goal of this model is that we really want it to be able to understand what these words mean, and then to be able to then make meaningful connections between concepts. So, for instance, gas and power are types of utilities. We want the model to be able to kind of have an understanding and make that type of connection, such that if someone is using our interface and they're searching for utilities, it knows that if a lesson learned talks about gas or power or something like that, that would be relevant to that search, even if they're not explicitly using that word utility or utilities. So we want to essentially go beyond of just like the spelling of a word, just the raw text of it, would actually go and understand the meaning of the concepts that are involved. And then we're going to use that, and we're essentially trying to build this kind of intuitive search system such that when you're entering in a phrase or some keywords that you're searching for, that the system really kind of tries to understand what it is that you're searching for and can help you to then kind of better find things. So one example of kind of how the model might understand something, and these are kind of actual things that are popping out of our model, is that if the concept of being underground, it knows is related to, you could have tunnels, or you could have underground power lines, or you maybe have a pipe underground that's leaking. So it's starting to kind of make those connections. And it also does it not just in terms of individual words, but in terms of combinations. So if we take power and also say in the context of overhead, we know that combined that might be talking about power transmission, power lines, things like that. So it's really trying to take it a step higher than just that text to understand the concept of what you're trying to search for, so that we can give you both recommendations of other things to search for, but then also the results that we're returning are based on the meaning of those words and not just the text itself. If we can go to the next slide, we have a short demonstration of kind of the system we've been working on. If we can play that video. So this is kind of a mock-up of our search functionality. Eventually this would be incorporated into the Clear site properly. But it's kind of a standard search interface on the face of it, but underneath what's happening is the model is actually going to be doing the search results and also giving you suggestions. So if we're looking for utilities here, maybe we want to talk about electric, maybe misunderstandings about utilities, underground utilities, utility disconnections. And then it's also just including other terms that are relevant. Like if we search for utilities, it's automatically going to pop in with utility. And then, so the next thing we can do is we're going to actually just refine that search and say, okay, tell me about wet utilities specifically. And then that's going to refine those results. It's going to be looking for the specific phrase there, and then also trying to understand what that specific phrase might mean instead of using the words individually. So we don't necessarily care just about wet or just about utilities, but what are wet utilities? And then kind of moving on to another example here, we're going to search for a hurricane. And this is kind of going to show you some of the different types of concepts we might be interested in. We might want to say, have some lessons learned about the kind of the destruction a hurricane can cause, or maybe like injuries, maybe onshore or something like that. Really trying to help direct you in places that you may or may not know that there is information there in the database to kind of search for. So here, if we take the example of moving on to an easement, again, we might be looking at like relocations, permits, stuff like that. So it's kind of just giving you different directions that you can take it to try and guide you through the lessons learned database in a more kind of intuitive way. The next example that we have here is just about bridges. Again, kind of just trying to show you some different examples of things that the model understands, like say, this is kind of an interesting one of like a tunnel might actually be related, or kind of a different direction to search for something. And then you can see that the lessons learned and best practices that are showing up are going to be kind of relevant to that concept. And then the final one here I wanted to show you was railroad, where here the model also understands that railway essentially has the same meaning, so it's going to go ahead and already include results for that, not just railroad. It's also going to understand acronyms like RR are going to be related to that. And again, it's going to suggest to you some of those kind of other searches that are going on. But underlying this, the important thing to understand is that the model is using that semantic understanding of words to give you results that may not necessarily include the word that you're looking for directly, but are related to that concept. Okay, and then I'm going to hand it back off to Arnav on the next slide.
So, so some of the challenges that immediately sort of we started running into is that general language models, they can't handle technical language, right? So construction, there is a very specific vocabulary. Colin mentioned acronyms. They're all over the place. For a computer scientist, to look at some of like a feasibility study documents, sort of interesting, right? With half of the acronyms that you don't get. The language model is even worse off because it doesn't actually have a sense of semantics. So, so on the one hand, we are at a point where we've started making progress on coming up with something usable, but we also think that this feeds back into AI research for us because it's a challenge for general language models to specialize to particular domains. We also have started realizing that as we are slowly sort of in the process of deploying this, research lab implementation to the actual CLEAR website that NCDOT will start using, that language models need to be constantly updated and improved over time. So there's sort of a training aspect to it, and then there's sort of the model, the interactive aspect to it, and then this constantly needs to be updated as more and more documents become available, as changes happen to through the vocabulary that is being used. And so for deploying something like this, the NCDOT over time will require some internal technological as well as domain expertise. So this is an interdisciplinary endeavor where you need both sort of computer scientists and people who actually understand the domain very well to work together. And so, and as you can see, like this collaboration between the two departments and NCDOT has been sort of interesting and energizing on both sides. So next slide. And so now we're happy to take your questions.
Hey Ed, this is Dan Farr. As we sat back and listened to this very in-depth conversation, what could be identified as the true value proposition as we think about application going forward?
Okay, I'll start off and see if other people want to, if Claire wants to join in or others. But I mean, I remember working with a database, a lessons learned database a while ago, and I just found it to be so cumbersome to use. What I found was first I had to type in keywords that were identical to what I was looking for. So, if I wanted something about a utility, I could get, one answer. If I put in utilities, I might get different answers. So anyway, I guess the value that I see here. So basically, when you go into a database, a lesson learned database, just manually, it's kind of like you don't know what's in there, and you're just kind of like meandering around trying to find different things. Okay, and that's not very efficient. It's not very effective. And if project managers put in some keywords and they don't find things that are relevant, they're going to stop using the lessons learned database. Okay, they just won't use it. And so anyway, this is a completely different approach to going into a lessons learned database and actually letting the computer, with its intelligence, try to identify. It's like the project manager can give a keyword, but then the system is smart enough to know that there's other semantic relationships that relate very closely to that particular keyword that the person put in, and will help the project manager say, here are some other suggested words that are similar that I'll start doing a search for you. And by the way, here's a list of potential lessons learned, best practices that you might find interesting for your project. This is so much more dynamic. It's got so much more depth to it. It's not one-dimensional. This is multi-dimensional. So I think that's the value add, the way I see it. And I can throw that question over to anybody else on the team. Claire, our program manager, was, she saw something in it too. So I don't know, Claire, if you wanted to chime in on that.
Yeah, I think just like Ed said, that we see that there's a lot of value using the program and accessing the database and finding the valuable like pieces of knowledge. But everyone's super busy and is managing multiple projects. So the easier we can get it to them, and it's just going to make them start using it more and make those connections quicker. And overall, we'll start to see sort of an organizational knowledge shift where we start predicting future issues better. And that all comes from being a part of, participating and using the program. So this is a really good way to drive people there and get it, make it a little bit more robust.
So I might have a question then. Danny Dow here, ConocoPhillips. Would you consider, or is the option, the objective to have multiple, for instance, departments of transport that input into the database, even though you might scrub some of the details, whereas you have a large pool, or is it more to share the algorithm to be able to use the AI within your individual database? What's the end goal?
Yeah, I can try to answer that. So there are two parts of this project. So on the one part, which is the AI part, is a language model that understands or has these semantic connections that are related to transportation vocabulary in general. So we have trained it on textbooks, on feasibility study documents, and so on, right? So as Colin said, about 1 million words that all comprise of transportation vocabulary. On the other hand is the use of this model to for the specific NCDOT database, right, where the best practices and lessons learned entries are, along with metadata. So the same model that that we use for NCDOT with a different front end that is looking at a different database, the same model would be is easily transferable to a new data set. So the lessons learned do not have to be all collected in the same database, but if there are ones that cross-cut across states, for example, then they could be. So there are several ways to implement what we have developed here. I hope that answers your question.
Yes, it does. Thanks.
Okay. And Falah, you had a question. Do you want to bring that to the team?
Yes. Hello. Good afternoon, whole team, and thank you for informative and useful projects. Lessons learned is most of us are keen to know how to take it to next step. The question to the team, I'm talking from Saudi Aramco, so we have a similar challenge, and we think the technology AI is an enabler for a better, value, making from those, databases. Now the question was, have the team thought of two things that are lasting challenges for lessons learned? One is it all depends on the initiator or the provider of that lessons point of view. So it would require certain root cause to really go into how that, let's say, pitfall happened and how to even avoid it in the future. The other part is using more rich, let's say, images, videos to even, help the communications of that lessons. Let's say a next step of a textual communication way that we have enjoyed for past years.
Yeah, so this is a really deep question. One thing that language models like ours enable is not just semantics across words, but also documents. And so one of the interesting things to come out of this is that if you were looking for a lessons learned on a certain number of terms, you can actually also search for an entire sort of lessons learned text, and then say what are the semantically related best practices, for example, related to these lessons learned, as well as sort of what are the other lessons learned that are similar to this one across multiple projects, or for a particular location, for example. And so internally, what we are building is essentially a knowledge graph that there are many possibilities on how documents could be related. One thing that we are already starting to do is to say, if you have a project at sort of an early stage where there's sort of a feasibility study going on, then giving as input to the system this feasibility study document to see what are possible challenges, what are possible lessons learned from other projects that directly might apply based on the setup of this project or the components. So I mean, this is a little bit farther away, but it in some ways it sort of starts addressing your question of where does this go. Now I think images and videos are images in particular are interesting and to some extent feasible. Where the more challenging part comes is in diagrams, diagrams and sketches, right? Because AI is too far behind in trying to interpret that. And with images, we will have the same issue, is that we would have to train a very specific domain-specific image classifier, right? This is not just saying there is a face here and a car there. This is much more detailed, and the stakes are much higher, right? So the tolerance for getting it incorrect is less so than the general image search applications on Google, right? Where you could have 60% accuracy, it will be fine. But for this domain, the scale of the projects and the potential risks, we have to get it to a point where there's very little tolerance for error when we get to more complicated data types.
Yeah. Hey, Ed and Claire, I guess I have a follow-up question, and it's along the same theme here. How are you structuring your KPI, your key performance indices, and overall metrics to ensure that you're, maintaining the success that you're challenge yourself with? How are you structuring your metrics?
Yeah, so we have a qualitative metric system. It's like basically a questionnaire, and so it goes out to everyone in the department before they start using it, and then we just sort of check in. And that was developed with another professor at NC State to help us come up with those metrics. And then And so that's really how we measure the success of the program and the system. And it's questions about, you know, is it usable? Do you know where it is? Are you using it? And then there's a scale, a rating scale. So does that answer your question?
Well, that feels subjective in nature. I was thinking about what can the system provide you with data? In other words, every time you look, you know, how many times are people asking questions of it? Is the system providing a broader domain of answers each time? That's the kind of thing. And that's why I was looking more of an objective, system-driven metrics that shows that it's providing the value proposition that you've outlined. So just food for thought.
We do collect that also. And I don't know if Arnav had something he wanted to add to that, but we are collecting that.
Yeah, in fact, there was another project that related to creating a dashboard using Tableau. And Arnav and his group also helped develop that dashboard to collect that kind of, I think, quantitative data that you're referring to, Dan. And Arnav, sorry, I didn't mean to interrupt you.
No, actually, no. Thanks for that. That connects with what I was going to say. So on our side, on the AI side, we actually have a systematic sort of study plan where we are looking at the ranking. So the differences when you search, the difference of quality and relevance for the top searches that you get from the current Clear website versus the AI recommended ones. And we are also looking at coverage in terms of range of words that a particular user might use in a session. So for example, if you started searching one word, but you were given, 5 lessons learned, from the titles, you only chose to click one, and then you changed your search term. And it took you about 10 minutes to go over 20 to 25 lessons learned, but only 3 of them you found relevant, right? And so and with the system, then we look at a session that is sort of a 20-minute session and say, okay, was there more searching in terms of the range of keywords? How many of the system suggested keywords were included? And what was the overall number of relevant lessons learned that the particular project manager found? And once this system is deployed on the actual website, we would have all this data recorded from there as well. Does that answer your question?
Yeah, that's fine. Thank you.
So, Dr. Yala, this is Rodolfo Gonzalez from Occidental, by the way. A common barrier to all the lessons learned systems typically is the approach between pull and push data. I mean, what you're doing here, basically, at least from my point of view, is you're pulling the data in a very smart way and basically providing that data to the people who is looking for it. However, I mean, have you considered to expand this to something more dynamic, something that can actually look into the future? Just thinking loud here. Probably by having this model and you have access to a daily log of a typical job, by looking into the narrative of that daily job, you probably can start seeing trends and connect the dots in order to stop something that you already learned. Is that something that it could be taken as a follow-up step on this type of jobs?
Yeah, I think that's a really cool next step, right? That you can take. And so you mentioned pull versus push, and I really like that that sort of analogy. If we do have we have information about projects, a lot of documents before even they start, right? And so potentially taking advantage of that in the planning phases to to set up essentially as part of the workflow, you know, either pulling or actively pushing certain lessons learned and best practices to project managers and team members would be really interesting to explore as the next step. And we have the language model side trained already, so that would be that's a good idea.
Guys, anybody else has another question or comment to the team? I mean, we're about to reach the time limit for this presentation, and if no one has any comments or questions, I would like to give a big thanks and to the team for presenting this to us. And probably we need to stay in touch, because this is a topic that could definitely evolve to be a huge value added to our processes.